Good morning everyone. Welcome to my YouTube channel. So today I am going to discuss 2023 Tifr linear algebra problems and I will discuss the solutions of the problems. Okay, so let's start. The first question says that if A is a 4 cross 4 matrix with entries from rational numbers such that its characteristic polynomial is x to the power 4 plus 1, then A is diagonalizable in M4C. That means A is diagonalizable over the field C. Whether it is true or false, it is asked. Okay, so let's the solution. Here x to the power 4 plus 1 equals to 0. That means x to the power 4 equals to minus 1. So x to the power 4 equals to cos pi plus I sin pi. Then the solution of these equations are given here: x1, x2, x3, x4. We can easily see that all the roots of the equation x to the power 4 plus 1 are distinct. So that means all the eigenvalues of the matrix A are distinct. We know that if all the eigenvalues are distinct and if all the eigenvalues belongs to the field, then it is definitely diagonalizable over that field. Okay, so here it is asked about whether it is diagonalizable over C, and all the eigenvalues belongs to C, so definitely it is diagonalizable over C. It is a very simple problem and easy problem. Now come to the next one. It's a tricky problem. So it is asked that if A and B with two cross 2 matrix with entries from Z2 such that trace of A equal to trace of B and trace of A square equal to trace of B square, then A and B are same eigenvalues. So let's start the solution. So trace is basically a linear map from set of all n cross n matrix over the field F to the field F. We know that trace is basically the sum of the diagonal entries. So here the field is Z2, so it is basically a linear map from M2 cross 2 over Z2 to Z2. Okay, so this is the definition of trace in our question here. Okay, so take A equal to 0 matrix and B equal to identity matrix. Then definitely A square is also 0 matrix and B square is also identity matrix. Now trace of A equal to 0 and trace of B equal to 1 plus 1, which is 0 in Z2. Similarly, trace of A square is also 0, trace of B square is also 0. But eigenvalues are different. Eigenvalues of A both are 0 and eigenvalues of B both are 1. Okay. So that means this statement is basically false. Now come to the next problem. It is given that if A is a n cross n matrix with entries from real number such that for all invertible matrix B, AB equal to BA. That means if it commutes with all invertible matrix, then A is basically scalar matrix. Is it true or false? So actually this statement is true. You can prove it in many ways, and also you can see the proof basically using the elementary matrix like consider a matrix and then arbitrary matrix, then you can compute it and equate it, and then you find that all the non-diagonal entries are 0 and all the diagonal entries are basically some constant. But I am trying to solve it in a different way. It is also an interesting way. So let's start. So if A not equal to lambda I for all lambda, then I can always find out a non-zero vector in Rn such that AV not equal to lambda V. Okay, so I can always find out a non-zero vector V such that AV not equal to lambda V. Then definitely V and AV forms a linearly independent set. Okay, and now we know that we can extend any linearly independent set to the basis of the vector space. Here the vector space is Rn. I have two linearly independent vector V and AV, so I can extend it to the basis of Rn. Say B1 be the basis of Rn, I just add n minus 2 extra vectors and make a basis. Okay, so the basis is this. Now observe that if this forms a basis, if B1 forms a basis, then B2 also forms a basis, because AV plus V is also linearly independent with V, and since all the vectors V1 to Vn minus 2 are also linearly independent with V and AV, then we also get that this set AV plus V comma V1 V2 to Vn minus 2 is also basis of Rn. Okay. Now I can make a invertible matrix B, okay, such that B maps V to V, B maps AV to AV plus V, B maps V1 to V1, B maps V2 to V2, and dot 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 B maps Vn minus n minus 2 to n minus 2. Since it maps each linearly independent vectors to a linearly independent vectors, I mean it maps a basis to another basis, so definitely B is invertible. Okay. Now observe that B of AV is basically AV plus V. Now if it is given that A commutes with all invertible matrix, right? So AB equal to BA. So if BAV equal to AB plus B, then I can write it BA as AB. So ABV equal to AB plus B. Again BV, what is BV? BV is V by our construction. Then AV equal to AB plus V. That will imply V is 0. But we already assume that V is a non-zero vector, right? So that's a contradiction. So definitely AV and V are linearly dependent. Since AV and V are linearly dependent, so I can always have a lambda such that AV equal to lambda V. Okay, so we are done. Now come to the next problem. Given any monic polynomial fx belongs to Rx of degree n, there exists a matrix A belongs to M and R such that its characteristic polynomial equals to F. Actually, this is the statement of a companion matrix. I will not discuss it in a very detail way, because you can search companion matrix in Google, you will have enough information. Okay, I just write down the companion matrix. If Px be a monic polynomial looks like x to the power n plus an minus 1 x to the n minus 1 plus an minus 2 x to the power n minus 2, so dot 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 a0, then the companion matrix corresponding to this polynomial Px is looks like this: 0 0 0, and the last column first entry is minus a0, then 1 0 0, and the last column second entry is minus a1, and so on. So this is basically the companion matrix, and this matrix satisfies this equation, and the characteristic polynomial for this matrix is also this, and also the minimal polynomial for this matrix is the same this. So okay, so you can search companion matrix, and how we came up with the companion matrix. There is a concept of t-cyclic subspace and the cyclic vector, and after that we will end up with this matrix. So I will not discuss with it in a very detailed way. Later we can discuss when we make a video lecture on this topic. Okay, but just we can say that this is a companion matrix which satisfies this equation. Okay, so come to the next one. It is given that let v1, v2, w1, w2 be non-zero vectors in R2, then there exists 2 cross 2 real matrix A such that a v1 equal to v2 and a w1 equal to w2. This is also a false statement. If you have an idea the properties of matrix, it sends linearly dependent vectors to a linearly dependent vectors, and also it maps, I mean if AV equal to B, then ACV is basically CB. Okay, I mean if it preserves the scalar multiplicity property. So with using this concept we can make a counter example. Let's see. Say v1 equal to 1 0, v2 equal to 0 1, w1 equal to 2 0, w2 equal to 0 3. So a of 1 0 equal to 0 1 if it's so. A of 2 0 equal to 2 into a of 1 0, which is 2 into 0 1, which is 0 2. That is not equal to 0 3. So we cannot have such kind of matrix. Okay. So this is the counter example. So the statement is basically false. Now come to the next one. It is given that A is a n cross n matrix with real entries such that each entry non-negative, and assume that limit m tends to infinity a to the power n exists and it is B. Then we have all the entries belongs to 0, 1 set. I mean, if a to the power n exists, limit n tends to infinity, a to the power n exists, then say limiting matrix is B, then all the entries of B either 0 or 1. Okay. So if you don't have an idea that what is the convergence of a matrix, I will say it. Okay, so let's start the solution. Consider the matrix A is basically 1, 1 by 2, 0, 1 by 4. Then what is A square? Is this. A cube is this. A to the power n is basically this. Okay. Now you can think you can think n cross n matrix be the element of Rn square. Okay, we know Rn. What is Rn? So say A11 entries is basically the first entry of Rn square. A12 entries is basically second entry of Rn square, and so on. And then Ann entries is basically n square entry of n squared entry of Rn square. Okay, so you can think the matrix as a vector in Rn square. Okay, so here it is 2 cross 2 matrix. I take 2 cross 2 matrix, so I can think the matrix A as a vector in R4. So here is the vector 1 R in R4. This is the vector 1 comma half comma 0 comma 1 by 4. So A square is basically a vector in R4 such that 1 comma 1 by 2 plus 1 by 2 into 4 0 comma 1 by 4 square, so on. Okay, so you can easily observe a to the power n is this, and this series is convergent, right? 1 plus 1 by 4 plus 1 by 4 square is a geometric series, so definitely it is convergent. So a to the power n converges to, this is 1, this is constant term, this is 1 by 2 into 1 minus 1 by 1, 4, this is 0, this is 0, because 1 by 4 to the power n converges to 0. So basically I get 1, 2 by 3, 0, 0. So here is the B matrix is 1, 2 by 3, 0, 0. But here I have a term 2 by 3. But in question it is given that all the entries are either 0 or 1. So that's why it is false. Okay. So it is a very important concept. If you have learned numerical analysis, then you can see the matrix iteration method, that is Gauss-Seidel method, Jacobi method, and in that context you will see a term norm of a matrix, and you will see when a matrix converge. I mean, when it's what is its property, you will see learn the diagonal dominant matrix, this concept and everything. Okay, so that is completely a different thing, but in this context it is enough to know that to construct this kind of matrix and this will converge to this. So it is a false statement. Okay, so come to the next one. It is given, it is a simple problem but tricky problem. It is given that x1 be a non-zero vector in R2 which is fixed vector, and we are inductively defining a sequence that ax n plus 1, I mean n plus 1th term of the sequence is basically we operate A, the matrix A, on the x nth term. Okay, nth term. So xn plus 1 is basically axn. Here it is given the matrix A. The matrix A is a 2 cross 2 matrix, and this is root 3 by 2 half minus 1 by 2 root 3 by 2. If you observe it clearly, then it is a special matrix. It is a rotation matrix. So let's the solution. See the solution. It is this. So it is cos pi by 4 sin pi by cos pi by 6 sin pi by 6 minus sin pi by 6 and cos pi by 6. Okay. So this is basically a rotation matrix by the angle pi by 6. You can easily see that a to the power 12 is basically cos 2 pi sin 2 pi minus sin 2 pi cos 2 pi, which is identity matrix. Then a to the power 13 is basically a. Similarly, a to the power 14 is basically a square. Similarly, a to the power 24 is equal to again identity. Then a to the power 25 is equal to a. So here x2 is equal to ax1, x3 is equal to ax2. Now again x2 is basically ax1, so we get a square x1. x4 equal to a cube x1. So similarly x13 equal to a to the power 12 x1. Now a to the power 12 is equal to identity, so we'll get again x1. x14 equal to x2. So what is our given sequence x? Xn is x1, x2, x3 dot 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 x12, then again repeats x1, x2, x3 dot 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 x12, then again repeats x1, x2, x3 dot dot x12. So what does it mean? I have different type of subsequence which converges to different limit. Suppose you take x12n. This is a subsequence. See, all the terms of x12n is basically constant term. That is basically x12 because x24 is equal to x12 equal to x36 equal to x48 same. So x12 when this subsequence converges to x12, x12n plus 1 this subsequence converges to x1, x12n plus 2 this subsequence converges to x2. Now if you compute, if you take x1 be a vector like say 1, okay, is a fixed vector say 1, then you can see that ax1 is a different vector, a square x1 is another different vector. So we have different convergent subsequence, but xn is not convergent because it has different two subsequent which converges to different limit. By the definition of convergence, we can say that xn is not a convergent sequence, but xn has a convergent subsequence. Okay, so that's why first option is correct. It is basically a rotation matrix, which is an orthogonal matrix. You can know that its properties is a basic concept. Okay, so just you have to compute something, you can easily do it. Okay, now come to the next one. So V is a all real polynomial such that f0 equal to 0. Okay, the first statement says that V contains three linearly independent polynomials of degree 2, and the second statement says that V contains two linearly independent polynomials of degree 3. Which of the following statements is correct? It is asked. So let's say V is fx belongs to Rx such that f0 equal to 0. Let px be a polynomial which is in V. Say px equal to a0 plus a1x dot dot anx to the power n. So p0 equal to 0 by given condition, that will imply that a0 equal to 0. That means all polynomials in V have constant term 0. I mean all the polynomials which is inside the vector space V, which is given in the question, has constant term 0. Okay. So now if possible, p1x, p2x, p3x be three linearly independent polynomials of degree 2. Then p1x is basically a1x square plus b1x because p1x is also in V. So I know that all the polynomials in V have constant term 0, right? So p1x is looks like a1x square plus b1x, p2x a2x square plus b2x, p3x is a3x square plus b3x. So say c1 p1x plus c2 p2x plus c3 p3x equal to 0. Then if I can compare the coefficient of x square in both sides, I get c1 a1 plus c2 a2 plus c3 a3 equal to 0. If I compare the coefficient of x, then I get c1 b1 plus c2 b2 plus c3 b3 equal to 0. So I just do it as a system of linear equation where this is a 2 cross 3 matrix and this is c1 c2 c3, the solution vector. Okay, now you can easily see that any 2 cross 3 matrix you can think as a linear map from R3 to R2, right? So definitely its null space contains a non-zero vector. So I have a non-zero solution of C1, C2, C3. So I can have a non-zero linear combination of these three polynomials. So it cannot have three linearly independent polynomials of degree 2 because I just assume p1, p2, p3x be a arbitrary three polynomials of degree 2, right? Arbitrary three polynomials. So I can say that if I choose any arbitrary three polynomials then of degree 2, then they are linearly dependent. So the statement is false. Now come to the next one. It is asked that V contains two linearly independent polynomials of degree 3. So it is obvious. So take q1x is x cube plus x square plus x, q2x is x cube plus x square equal plus 2x, q1 0 is 0, q2 0 is 0. So definitely q1 and q2 belongs to V. q1 and q2 both have degree 3. and Q1 and Q2 are linearly independent. Why? Because if they are linearly dependent, they are basically scalar multiple of each other, right? But you can easily see that this one and this one are not scalar multiple of each other, so they are linearly independent. So it is, this option is easy, but this option is tricky. You have to solve it. Okay, you have to use the concept of linear algebra and linear transformation. So okay, come to the next one. It is the easiest problem. I hope all the students can solve it very easily. So T is a linear map from M3R to R3, defined as T of A is basically A of 1, 0, minus 1. Okay, so then it is of the dimension of kernel of T. So take A as a 3 cross 3 matrix, arbitrary matrix. Then A of 1, 0, minus 1 is 0, 0, 0. So after that computing, I get A11 equal to A13, A1 equal to A23, A31 equal to A33. So I have 6 different choices. Okay, A11, A12, A21, A22, A31, A32. I have 6 different choices for A if A is inside the kernel of T. So that means dimension is 6. So none of the 3 options are correct here, because it is 1, 2 and 8 options. So none of the remaining 3 options are correct. So option 2 is correct here. Now come to the next one. It is also a problem. It's a concept of inner product space unit. So define an inner product on set of all real valued continuous function on closed interval -1 to 1, and the inner product is basically given by this inner product of fg, basically -1 to integral -1 to 1 ft gt dt. Now ask that there is a subspace of this set of all continuous real valued continuous function, which is a vector space over real numbers field, and define the subspace that set of all even functions. Okay, set of all even functions which is inside this space, I mean this real valued real vector space of continuous function. Now it is asked that what is the orthogonal complement? What is the orthogonal complement of this space V? So first observe that for any function, any real valued function, fx can be written as a sum of a even function and an odd function. That is in this way: fx plus f of minus x by 2 plus fx minus f of minus x by 2. Say gx equal to this, then g of minus x equal to this. So gx equal to g of minus x, then definitely g is even, and hx equal to h of minus x, hx equal to minus of h of minus x, so definitely h is odd. Here I have done a mistake, it is minus, hx equal to minus h of minus x, so h is definitely odd. So any continuous function can be expressed as a sum of an even and odd function. So I have the vector space V as this set of all even function. So if I take G be any odd function which is inside this, and if I choose any even function from this, then the inner product of fg is basically -1 to 1 ft gt dt. Okay, I know that ft equal to f of minus t and gt equal to minus g of minus t. So I just replace it. That is f of minus t equal to minus g of minus t dt. Okay, now take minus t equal to z, then minus dt equal to dz, then the limit will interchange from 1 to -1 fz minus dz minus dz. So basically it is plus 1 to -1 fz gz dz. Basically it is minus of -1 to 1 fz gz dz. So I can have this one equal to this one, and both are same, right? So 2 into -1 to 1 ft gt dt equal to 0, that will imply -1 to 1 ft gt dt equal to 0. So inner product fg equal to 0. Okay, so let w is equal to set of all odd function which is inside the set of all real valued continuous function on -1 to 1. Now I have already given v in our question, and I just defined w in the set of all even function. So I just easily see that v intersection w is 0, right? And also I have seen that v can be expressed as a sum of the vector space v, I mean sum of the subspace v and the subspace w. So I can write down c minus 1 comma 1 r as a direct sum of v and w, since their intersection is trivial. Again, Again, for any inner product space, if I have a space, I have a subspace V, then I can write down the mother space as the subspace direct sum its orthogonal complement. So here V is basically, or V is V and its orthogonal complement are direct sum of this. So from these two I can conclude that V, the orthogonal complement of V is basically W. So how can I conclude from this to this? That definitely you will think, okay, I will not explain this is a simple thing, but you will think that why this is true. If V is direct sum of W, if C this vector, and if this space is direct sum of this subspace, and if this one is direct sum of this, then definitely both are equal. Okay, so here this is done. So in this question, this option, the option first, is the correct answer. Okay, so I just discuss all the questions except one problem. There was a problem of 10 cross 10 real symmetric matrix, and it is asked about say a to the power 10 number of positive entries of a to the power 10. So that is a difficult problem, and that takes more explanation, and I will make a separate video for that particular question because it takes lots of times to discuss. If I discuss it in this video, then definitely video becomes so much lengthy, so that's why I exclude that problem. All the other problems I have discussed in this video, all the linear algebra problems in 2023 Tifr exam. Okay, so if you have any doubt, you can ask me in the comment section so that I can reply you. I hope you can understand. And if you don't know the concept, if you don't know the definition, like if you don't know the definition of inner product space, then definitely you will skip this video. First read the definition of this thing, and then we will solve. Okay, the problems are not so much difficult. Some of the problems are tricky and some of the problems are difficult, but other problems are moderate. Okay, it is easy to moderate if you have concept. If you know the concept very well, if you think it properly, then you will definitely solve it. Okay, so thanking you, thanks for watching. Please subscribe. Okay, and please share to your friends. Thanking you.